Power transformers are used throughout the utility grid's electrical distribution system. They're used for stepping up or stepping down the voltage. Both types follow the same electrical principles to increase or decrease the electrical voltage distributed. The utility power grid uses two types of transformers. Step-up transformers increase voltage when power is distributed over long distances, and step-down transformers decrease voltage to the level required locally by utility customers. At the center of a step-down transformer is an iron loop. This is the transformer core. On the input side of the transformer core are wound the primary winding coils. On the output side of the transformer core are wound the secondary coils. In a step-down transformer, the secondary coils are less than the primary. The ratio difference is determined by how much voltage reduction is required. When the AC power input is connected to the primary coils, the primary input AC voltage flows from positive to negative per the principle of electromagnetism as the current flows through the primary coils. A magnetic flux or field is generated in the transformer's iron core. Following a principle of electromagnetism, the magnetic field of the iron core will then induce an AC electric current to flow from minus to positive in the secondary coil's output, providing a step-down secondary voltage. The voltage step-down is dependent on the ratio of the primary coil windings, and the secondary winding turns on the output coil. The bigger the drop in turns, the larger the drop in output voltage over input voltage. In a transformer, the ratios between input to the primary coils and output from the secondary coils are used to calculate the required inputs and outputs. Power is a function of amps or current times volts. Therefore, the primary IP times primary voltage, Vp, flowing in the primary coils equals the ratio, amps secondary times secondary voltage, Vs, the output flowing in the secondary windings. The difference between the input and output of a transformer's current is defined by the amperage to turns ratio of the primary and secondary number of coil turns. As depicted in a step-down transformer diagram, there are less coil turns on the secondary than the primary, and the opposite for a step-up transformer. The amperage per turns ratio, with the current flowing in the primary coils, is expressed as IP for primary current input over IS for secondary current output amps, equals NS turns on secondary coil over NP turns on the primary. The output current on a step-down transformer will increase as the voltage decreases. In a step-down transformer, voltage to turns ratios are used to determine the output voltages based on the input voltage and the primary and secondary turns ratios. Again, using a step-down voltage transformer diagram, the ratio formulae are now based voltage to turns ratio, Vs over Vp, equals Ns over Np. Therefore, in a step-down transformer, when the primary input voltage is 240 volts and the turns ratio is 2:1, whereby every two primary coils there is one secondary coil, the secondary output voltage is 120 volts. It's important to note, no machine is 100% efficient. Transformers have efficiencies at full load between 95 and 98.5%. Losses occur due to copper loss, due to ohmic resistance of the transformer winding. The loss is dissipated as heat. Eddy current losses. Magnetic flux creates eddy current losses in some part of the transformer that also dissipates as heat. And hysteresis loss in the transformer, due to the reversal of magnetization, especially with lower grade iron cores. If you have questions regarding transformer operations or how they may work within your system, please contact your trusted generator provider.